Hi there, my name is Chris Harris and I'm from AlleryTutors.com, and in this video we're going to be looking at group 2 elements and their physical properties. So just an overview, we're going to look at electron configuration, we're going to look at atomic size of these things as well, melting points and ionization energies. So just briefly, just a quick intro to what group 2 elements are. They're obviously found in group 2 in the periodic table, and they're normally called alkaline earth metals because of the compounds that they form are alkaline. They are found in the S block of the periodic table, so on the left hand side, and they are metals, so they will form metallic bonding, and that's really important when we look at physical properties of these things as well. So you need to have that right in the forefront of your brain. Okay, so we're going to start with electron configuration. Like I say, these things are S block elements, and I've got two elements here, the electron configuration of them at the A-level standard. So this is the 1s2, 2s2 for beryllium, which is right at the top of group 2, and magnesium is 1s2, 2s2, 2p6, 3s2. The ions that these normally form are 2+ ions, so hence they lose their 2 electrons in their s orbital, and these are the electrons in the outermost orbital. So that's pretty straightforward there. In terms of atomic size, these things, as we go down the group, they get bigger. So we say the atomic radius gets bigger, and this is important when we look at ionization in a bit. And the reason why they get bigger is because we've got an extra set of shells that are in between the nucleus and obviously the outer part of the atom. So I've just drawn a diagram there to represent the first 3 in group 2, and you can see that the atomic radius gets larger. Okay, just looking at melting points. So melting points, we are looking at going down the group, so starting from beryllium to radium, and generally the melting points of these things decrease as we go down the group. There is an exception, which is magnesium, as you can see here, and that's the reason why magnesium is slightly lower, well, it is significantly lower, is because of its structure, and you're not required to know about that at A-level chemistry, but there is a slight blip on there. But you can see generally there's a decrease in the melting point of the elements. Now the reason why is because, remember, if we come back to this where we said these were metallic bonding. Now in a metallic bond you have positive metal ions, and then you have a sea of delocalized electrons that have come from the original atom of that metal, and they kind of cover the surface of the positive ions. So all of these metals, these are all group 2 metals, so they all can donate or give up 2 electrons to form the delocalized sea of electrons. So they all give up the same number. But if we come back to this concept here, which is the atomic size, the ions effectively get bigger. And what that means is that the sea of electrons are spread over a much larger area. So the density of the electrons is effectively reduced because it's been spread over a larger place. So it's a bit like, the best way to describe this is a bit like bread or toast, and you have jam on there. So the toast is effectively like the ions, or the group of ions. This is the giant metallic structure, and the jam is like the electrons. So imagine we had a fixed amount of jam because all of these produce 2 electrons, and let's say the ions, as we go down the group, the slice of bread is getting bigger and bigger, but we have a fixed amount of jam. Now for the small atom, like beryllium, we have a small slice of bread and a fixed amount of jam. We spread it over and we can get a really good thick covering of jam over the top of that. A bit like the electrons being spread over the positive ions. And as we go down the group, obviously when we get to somewhere like elements like barium, barium's got a very large ions, but the same number of electrons. They have to be spread over a larger area. So this is effectively like a large slice of toast or a large slice of bread, same amount of jam. That jam has to be spread over more thinly, and therefore the attraction, effectively the metallic bond, is the attraction between the delocalized electrons and the positive metal ions. And if them electrons are spread over a larger area, obviously the attraction is reduced, and this has an effect on the melting point of it, because the forces required, or the energy required to break these forces of attraction between the electrons, delocalized electrons and positive ions, are much reduced. So these are the key points that you need to say when you're answering your exam question, is to do with the delocalization of the electrons and a weaker attraction between that and the positive ions, because they're spread over a larger area because the ions are bigger. Okay, just coming on to the final point, which is ionization energy. Ionization energy is the amount of energy required to remove 1 mole of electrons from 1 mole of a substance in its gaseous state. And you will need to remember that definition for A-level purposes as well. But again, we've got our group 2 elements. We remove an electron. This is the first ionization energy. So if we line up all our elements, remove 1 electron from each of the different elements as we go down the group, effectively the ionization energy decreases. So therefore, it's a bit easier to remove the outer electron. And the reason why is because the atom's getting bigger, so removing an electron from the outer shell here is a lot easier than removing an electron from the outer shell of beryllium. And the reason why is because bigger atoms have more electron shielding, and we have a larger atom. So trying to remove an electron from there is a lot easier. And just remember, the reason why is we have a positive nucleus in the middle, and the reason why the electrons are effectively around the atom is because they're attracted to the nucleus. So if they're further away from the positive nucleus, then effectively the ionization energy is reduced. And effectively, we're not going to look at chemical reactions here, but there is a video that looks into chemical reactions. If you just check out my playlist for Group 2 and S block elements, then you'll see about the chemical reactions of these things. But effectively, as we go down the group, these things become a lot more reactive, mainly because the electron cannot be held so easily by the atom. Very similar to Group 1 metals. But that's it. Hope that helps. Bye.